Okay, we are now in lesson 26, and it has a very fun title called More Complicated Equations. So we are just going to jump into examples on how to solve these equations, because there's really not much else to learn. It's just practicing things that are just a little bit new. Okay? So here is an example from page 112. This is practice problem A. Excuse me, 3m minus 7m equals 8m minus 6. Okay? So what we are wanting to do is we're wanting to get all of the m's on one side, right? Because we want it to say m equals something. That's how we solve for it. So right now we have two like terms here, 3m and minus 7m. So if we add those together, 3 plus a negative 7m, one is positive, one's negative. You subtract, you keep the negative sign because 7 is the bigger number, equals 8m minus 6. Okay, so I'm going to move this m, this 8m, over here. Just like we've done in the past, if I want to move something that's being added, I have to subtract it because 8m minus 8m is 0, right? And 0 minus 6 is minus 6. Now we have a negative 4 plus a negative 8. Both are negative, so you add them together, keep the negative sign. Okay, so negative 12m equals negative 6. We want m to be by itself. Right now it's being times by negative 12, so to get rid of that, we do the opposite. Negative 12 divided by negative 12 is 1. 1 times m is m, equals 1/2. I just went ahead and reduced that. 6 divided by 6 is 1. 12 divided by 6 is 2. Both of them are negative, so the answer becomes positive. M is going to equal 1/2. So another example from this lesson 26 is letter B, which we have written up here on the board. 5 minus 6p equals 9p minus 7 plus 8p minus 3 plus 2p. To start off with, I marked down like terms, this 9p, this 8p, and this 2p, and I'm going to add them together. 9 plus 8 is 17. 17 plus 2 is 19p. Then we have a negative 7 and a negative 3. So we're going to add those things together. They're both negative, so we add. And we get 10, but we keep the negative sign. So it's 19p minus 10 equals 5 minus 6p. Okay? Now we need our p's to be on one side and our other numbers to be on the other side. So I'm just going to move them this way so that my p isn't negative. So I'm going to add 6 here and add 6 here. Negative 6 plus 6 is 0. 0 plus 5 is 5. 19 plus 6 is 25. P minus 10. Okay, so that's what we have so far. I'm going to move this 10 over here so that we have p on the same side. Those cross out. Negative 10 plus 10 is 0. Okay, so now we have 15 equals 25p. I'm going to divide both sides by 25. That becomes 1. 1 times p is p. P is going to equal. I'm going to divide both of these by 5 so that I can reduce them. So 15 divided by 5 is 3. 25 divided by 5 is 5. So the answer to this big, long question way up here is 3/5. So if you put 3/5 in for p, it will make it a true statement. So that is our solution, 3/5. Let's work through one last example from the book. This is letter D, page 112. We have 3p plus 7 minus a negative 3 equals p plus a negative 2. So I'm going to start simplifying where I can simplify. So this is going to be 3p and a negative, negative 3, those become positive. So this becomes plus 10. And I have two signs, a positive and a negative, and that becomes a negative. So I'm just going to simplify it like this so it makes a little bit more sense to me. I want my p's on the same side, so I'm going to subtract this p from both sides of the equation. The -2 stays, the 10 stays, and then 3 minus 1 is 2p. Those are adding like terms. Okay, now I need to subtract 10 from both sides because I want p to be by itself. 2p equals -12. And then we divide this by 2. P equals -6. So if you put -6 into your equation, you're going to get the right answer, a statement that is true on both sides of the equation.